To truly understand Android, we must look at its evolution, not just the candy-coded names, but the deep architectural milestones that define the platform for developers. The foundation era began with essentials. Cupcake, for instance, introduced the input method and app widget frameworks, establishing the core building blocks for applications and user interaction. Performance soon became a priority. Froyo brought the Dalvik just-in-time compiler, a clever machine that dramatically sped up how applications run, making everything feel more responsive. Ice Cream Sandwich was a landmark moment, unifying the user interface for both phones and tablets, and introducing hardware acceleration for a smoother, more modern look and feel. Then came Jelly Bean and Project Butter. This wasn't one feature, but a collection of deep enhancements like VSync timing and triple buffering, all aimed at one goal: a flawless 60 frames per second experience. A new era began with Lollipop. The aging Dalvik virtual machine was replaced entirely by the Android Runtime, or ART, which featured ahead-of-time compilation for a massive leap in efficiency. Lollipop also fortified the system's defenses, enforcing SE Linux across all domains. This created strict security boundaries, isolating processes and protecting the core of the operating system. With Marshmallow, control shifted to the user. The runtime permission model was introduced, forcing applications to ask for your approval to access sensitive data when they needed it, not before. Nougat tackled the pain of system updates. A/B seamless updates allowed a new version of the OS to be installed in the background on a separate partition, ready for a quick reboot. The next era brought the most profound architectural shift yet. Android Oreo introduced Project Treble, a massive re-architecture of the entire OS framework designed to speed up updates. Treble separated the core Android OS from the device-specific software written by chip manufacturers. A new stable interface connected them, allowing the framework to be updated on its own. Pi continued this refinement, enhancing the Neural Networks API for on-device machine learning and implementing stricter limits on how apps could run in the background, saving battery life. Then came Android 10 and Project Mainline. This brilliant move modularized core OS components, allowing them to be updated directly through the Play Store, just like an app. The latest era focuses heavily on privacy and modularity. Android 11 introduced one-time permissions, giving users even more granular control over their personal data for a single session. Android 12 brought a major UI overhaul with Material U, but also key architectural changes. It added a new system partition and enhanced privacy indicators for camera and microphone access. 13 continued the push for modularity by expanding Project Mainline even further. It also introduced the Photo Picker API, providing a safe, standardized way for apps to access media. And with Android 15, we see a new privacy frontier, Private Space. This creates a separate lockdown profile on a device, hiding sensitive apps and data from the main user space. For an Android OSP developer, 3 milestones are the most critical. First, ART, which completely changed the fundamental app execution environment away from Dalvik. Second, Project Treble. This enforced a strict separation of the system and vendor partitions, revolutionizing how the Android hardware and software layers interact with each other. And third, Project Mainline. By modularizing system components into updatable packages, it broke the dependency on full OS releases for critical security and feature updates.